In March 2026, the United States Central Command announced the strategic deployment of B-2 bombers for Operation Epic Fury. These bombers deliver long-range fire designed to eliminate high-value targets and prevent hostile regimes from rebuilding their military infrastructure. This deployment highlights the central paradox of the B-2 Spirit. It is the most expensive and destructive strike weapon in history, yet it remains physically delicate. A surface gap the width of a credit card or a temperature shift of only 5 degrees can render the entire $2 billion platform useless. The B-2 survival depends on an obsessive, climate-controlled ecosystem of maintenance that begins long before the pilot ever reaches the cockpit. Early attempts at stealth focused on visual transparency. In World War I, German engineers covered prototypes like the Linke Hoffmann RI with Cellon, a cellulose acetate material. It failed because sunlight glinted off the surface, making the aircraft more visible to observers. The B-2 uses a different approach, radar-absorbent material. This coating contains tiny iron spheres that vibrate when struck by radar waves, converting that electromagnetic energy into heat. Maintainers treat the application of this coating as a dark art. They must sand the surface to within thousandths of an inch to ensure the aircraft remains invisible to enemy sensors. Environmental factors like heavy rain or a bird strike can easily chip this fragile skin. These imperfections act as a beacon, reflecting radar waves and revealing the bomber's position. Moisture is an equally dangerous enemy. In 2008, a B-2 crashed in Guam because moisture built up inside its air data sensors. These sensors provide critical altitude readings. When they failed, the flight computer commanded a stall that destroyed the aircraft. B-2 maintenance requires technicians to electromagnetically sculpt the aircraft's surface, treating physics as an unforgiving opponent with zero margin for error. This sensitivity extends to the weapons bay. Technicians prepare JDAMs, gravity bombs converted into precision-guided munitions, inside facilities locked at exactly 68 degrees Fahrenheit. A 5-degree temperature swing causes the ring laser gyros to drift. These gyros are internal sensors that detect the bomb's movement. If they drift, the weapon will miss its target. To maintain precision, the bomber communicates with the bomb through a physical umbilical connector, feeding it vital targeting data. The weapon stays inert until seconds before release. Only then does the B-2 flood the processor with coordinates, allowing crews to adapt to targets in flight. Ground crews also perform hot pit refueling, a high-speed evolution where fuel is pumped while the aircraft's 4 engines remain running. Technicians pump 600 gallons of fuel per minute, while the engines generate heat capable of melting solid aluminum. One spark near the bare metal grounding points would result in a catastrophic explosion. Every B-2 mission is a race against time and temperature. A single mechanical or thermal oversight can prove fatal for the crew and the mission. Despite its power, the B-2 fleet is small, aging, and increasingly expensive to maintain against modern threats. Global competition is rising. China's H-20 bomber, for example, uses a similar flying wing design and is built to challenge the B-2's long-standing dominance in stealth. To stay relevant, the B-2 uses tactical integration to share data with F-35 fighters. These jets utilize sensor fusion, the process of merging data from multiple sources into a single view, to extend the bomber's situational awareness. The Air Force is already preparing for the future with the B-21 Raider. This successor is designed with a modernized stealth architecture that is far more sustainable and easier to maintain than the B-2 Spirit. Until the Raider fleet is fully operational, the B-2 remains the primary weapon for penetrating the world's most sophisticated air defenses. The B-2's actual invisibility is maintained by thousands of unseen human hands, working daily to keep this advanced machine airworthy against the unforgiving laws of nature.